So, welcome back, everyone. Now it's my pleasure to introduce Dr. Gerold Schneider. He is the leader of the Text Crunching Center at the University of Zurich. He has studied English and computational linguistics. His doctoral degree was on syntactic parsing and his habilitation on the application of computational methods in linguistics. He has published over 120 papers on parsing, text mining, content analysis, corpus linguistics, and digital humanities, with a particular focus on interdisciplinary approaches. Welcome, Gerold.
Thank you. Thank you very much for inviting me. I'll talk to you about our Text Crunching Center and about methods, particularly data-driven methods that we use for interdisciplinary research. So first about our customers and our center and some of our experiences, and then indeed I'll focus on methods by case studies. There are many additional methods, but I'm not going to go into them, and probably we're not going to get through with all the case studies. So our center, of course, yes, at the University of Zurich. We are offering expertise in several areas, generally speaking, text analytics, text mining, sentiment detection, or everything digital, humanities, but also machine translation. So what do we typically do? We offer support and consulting in digitalization projects, in processing of texts. We can include multilingual and historical texts, or we give advice on tools, software, and best practices. We help people with project applications, which are then becoming common projects, or we program ready-made solutions. We're a young team. We were founded in 2020. We're a small team, 2 postdocs, Tilja Ellendorf on the right and me, and several student helpers. Our customers come from 3 categories. On the one hand, there are University of Zurich internals, which are about 50% of our customers, academics worldwide, about a quarter, and private industry, yet another quarter, roughly, of our customers, but about 50% of our revenue. We use many tools. Here are the most important ones: Python with many libraries, R with many libraries, and many further tools, some of them GUI tools like Lightside or Gephi. The added value, I think, is that we're more efficient than, for instance, a doctoral student. We're very applied, so we can apply state-of-the-art methods, and we focus on performance and applicability. Simon has told us that, yes, if it's good enough to do the job, then that often helps. We have often very small, precisely defined projects and services, so we're supposed to do OCR over so and so many pages. And of course, we're also very well networked with the Institute, but also with other research platforms. I'd like to talk a bit more about some of our data, which is unstructured data. Textual data is often called unstructured data. In addition, it's often also unlabeled. So besides the supervised methods, we also use unsupervised data-driven methods, which we find particularly interesting here, often because there's no gold standard. Well, in the case of patient data, clinical text, for instance, there can be the diagnosis, but there's usually much more in the text. Many of our customers also don't really have a clear hypothesis. We also heard that from Rodrigo, so they want exploratory research. In German, this is also nicely summarized by the difference in clinical text between Befund and Befinden. So on the one hand, you have the diagnosis, but how do the patients feel, and their rich world can hardly be caught in a binary distinction of a diagnosis. So new patterns in data-driven research, new correlations can be detected or assumed ones confirmed. We also want to help the patients in the clinical text scenario, which is one of the scenarios that we have, coping strategies and helping people to find patients with similar concerns. So this is just a little motivation for this. Doctors are seeing patients and carefully documenting their conditions and so on. and medical histories, and there are also patient reports, and the bulk of the data is not discrete fields, but free texts, and this is generally under study. So I'm going to focus in this talk on unstructured data and texts. First, a few more words about our experiences. So what we found out is that indeed more of our customers wanted exploratory unsupervised research than we had expected. Many do not really have a clear hypothesis, so exploratory research is thus important. Also, coaching and teaching is more demanded than ready-made solutions. The customers want to be a part of the process, and they want to be able to use these methods afterwards. So there's really knowledge transfer, which is in demand. And for this, yes, we use, for example, R notebooks, such as shown in the example here, Jupyter notebooks, many additional tools, and we'll now give you a showcase of some of our customers' data. Our experiences are that teaching of workshops and creating online teaching material is also more demanded than we had thought. Common projects applications are quite popular. And yes, there are many challenges in exploratory and data mining research. Expectations are often, well, both too high and sometimes also too low. So some people are really are then surprised how exciting. Others, yes, this is not doing the magic that we expected. Rodrigo also told us about this. The background and the previous knowledge of customers is extremely varied, and technical coaching for non-technical people can indeed be challenging. It's also another challenge, hard to draw the line from our free services, initial help, a bit of brainstorming, up to until they finally then hopefully accept the offer. It's also very hard to know if a potential customer will accept the offer or not. Now I would like to give you a couple of case studies which also show you we're now moving back to textual data, as we have also seen it in the very first talk. So, of course, topic modeling is going to play an important role here. And we show here one of our studies that was done on the Hansard Corpus British Parliamentary debates from 1803 to 2015. We've used 100 topics, and here we see some of the topics, how they develop time series over time. So we see clearly mirrored historical facts, for instance, such as World War II, or the role of Ireland, which was very important during the independence movement, but fell off immediately after that. And we were interested in democratization processes here, which for instance happens through technical innovations, but also through education. So here we have mandatory education and university and science. And social protections. You would perhaps think of labor, trade unions and so on. That was important at some stage, but not later. What's most important now seems to be family and childcare and health and medicine. As a next step, we wanted to correlate these time series with metadata, and one metadata that was particularly interesting was democracy indices. So here we have Pearson correlation with democracy indices. Unsurprisingly, this topic here, which has the keywords colony, slave governor, and so on, is a very strong negative correlation, but that's, of course, not surprising. We find very strong positive correlations with democracy indices when it comes to here entrepreneurship, for instance, company, business, private, profit, firm, then childcare, information society, or this one is also quite interesting, water, oil, energy, gas, electricity. That gives a new reading to the catchphrase, power to the people. Another method, and here I briefly introduce it, is conceptual maps, which is a distributional semantic method. Like classical distributional semantics, the idea is that semantically similar words often co-occur in the discourse. Here we, for instance, see from a large corpus how horse and ride are distributed. They have a bit of an overlap, perhaps not as strong as an overlap as we would have expected, and then we use kernel density estimation as a strong smoothing method to place those terms that are similarly distributed in similar places in the map. For a customer in food industry who was interested in associations that people have on beer, cider and wine, we did this, and everything done here is fully automatic except for the color that I have added. So up in the wine color, here we see that, of course, wine is served in glasses, it's white or red, it's drunk. It also is related to nice dinner. It makes one tired. It's a very female topic, so we have mom, baby, girl, bitch as well here. If we compare that to beer, where it's about games of football, it's in the bar, it needs to be cold from the fridge and so on. It's a man, it's a very male topic. If anything is eaten, then it is pizza. So we have a totally a different world here. I think I'll skip, or I just say one word about cider. This is much more about the season of autumn. It has experiments with herbs, for instance. Of course, it's related to apples. And everything in this map makes sense. Also, things that stand in the middle, candles, for example, can appear together with cider and together with wine, but not with beer, while pint, which just flicked past, is between cider and beer. We can also use this on many other, so here we do use it on patient data, so these are experiences of patients in the intensive care unit. Here we had a corpus of only 8,000 words. Any distributional semantic method is just going to fail on that because it's really too small. But still with this method we could get some interesting insights. In green we have the core complaints that concerns that people have. Then we have individual journeys in red and some shared problems in blue. Here we see several paths crossing, so there are many people who, for instance, wear earplugs. They're bothered by annoying machines and so on, or they use headphones against that. Here we have someone hallucinating. He believes, a guy who was anonymized, to Zacharia, that he is kidnapped, strapped to the bed, and so on. So we can really explore graphically these journeys, and because we have so little data, we actually often see the individual texts also mirrored in here, but this is a sort of high-level abstraction which immediately gives us an overview of what happens in a corpus, be it small or large. Distributional semantics proper also allowed us, for instance, to look at patient data. Here's another example where we used multiple sclerosis patient interviews, and the most similar word for together with Leben, this is a German data set, for example, is Serenity, Gelassenheit, or Relationsbeziehungen. So it's really amazing how these patients manage to focus on what counts in life, but similarity to Körper, of course, you cannot fight the physical situation that is involved in this. Of course, you also use supervised approaches such as document classification. Here a little teaser on US speeches that was before Donald Trump, before 2013. The question is, can we detect if a Republican or a Democrat is talking, just given the speech? And yes, it actually works very well. We have a performance with logistic regression of 95 to 98% accuracy. And then you can also look at the features. And here we have the most typical Republican features. We have, for instance, contractions, but also the usual suspects such as nation, freedom, government, American military, while the least Republican features, so these are features which least frequently point to Republican, are National Rifle Association, which is a big donor, but no one wants to talk about. Anything that is related to climate or service program, fugitives, stalkers, etc. So these lists are quite easily often interpretable. I'll now briefly, how many minutes do I still have? Give you a very short summary of some slightly more involved projects. The first one was about cognitive aging. So here we used conflict conversations, and the question was, how much does our speech facility ability decline with increasing age? Here we've used a classical method of logistic regression, and we showed, for instance, that quadratic regression works better than linear regression. So there's an increase here, the frequency of disfluencies, but at the very late age, it actually decreases again. There are fewer and ers in your speech. Or here we have the clause length, which also peaks and then later on gets smaller again. Of course, it's also worth to look at things in more detail. So concerning clause lengths, we've, for instance, observed, perhaps I'll show it mainly here, that while subordinating clauses, in red we have the oldest age group, really the length really decreases a lot. But coordinating clauses stays roughly the same, so there seems to be a decline in using argumentative style, while the narrative style, blah and blah and blah, seems to be totally unaffected. Further, case where we've used a natural language processing model, we want to know how difficult are texts to read and where do language learners face particular difficulty, for instance, due to their language. For this, we've used a simple language model which is called surprisal, which is the probability of a word to come as the next word in its context. This is an information theoretic model, so Shannon's noisy channel comes in here. And it's also said that successful communication, because we want to transport a message, on the one hand has to surprise us, but on the other hand, if it surprises us too much, the communication, as Shannon says, really breaks down. And if we look at the certain genres, then we see that in the spoken genre, here in brown, this actually really works fairly well, while in the scientific genre, we all know the word limit constraints. This is pushed extremely far to the complex end. I'll skip the psycholinguistic background, so that it's really surprising how well this works with the expectations, and then we can look at surprisal and other features in order to find out how much they correspond with reading times in eye tracking. Here are the features that are used, and we actually manage to predict an average speaker fairly well. And perhaps as one last application, we can then compare native speakers and advanced language learners, and we see the surprisal, which is about the probability of the word in its context, is a much more significant feature for L1, for native speakers, than for L2 language learners, because indeed, yes, for them, sequence information, collocational knowledge is much less around. So, to conclude, I've shown you our staff, our customers, our experiences, and I have given you a little insight into some of our case studies, and I'm happy to take questions.
Thanks a lot, Gerold, for this very interesting talk. And now I know who to call if I need advice on NLP.
Thank you.
So do we have any questions from the audience? So I see a raised hand.
Hi, Gerold. Thank you for the talk. It always brought me back to my student days with Gerold. So how did you find the customers or the projects? Is it bilateral, or the customers approach to you, or you find joint interests in collaborating with different professors?
Right, a bit of everything. So some people contact one of our professors who then tell them, do go to the text crunching center. Then sometimes also research that has been established. One asks them what they want to do, or of course in the beginning we also had a bit of publicity for our center, but there are many different models, or it's by word of mouth. So someone wants to apply for a project and is wondering, do I really want to hire a doctoral student for that, or has a data set and says, I want to see results relatively quickly, a conceptual map, for instance, as we have seen it here. So just focusing on the CIDR again, and then we can do such an exploration or a topic model to get an overview of the data fairly quickly, and then more things can follow from that.
We have another question from Simon.
Sorry about that. Yeah, so I don't know whether you looked at it, but do you expect to see differences between, I mean, in some of these metrics between different languages? For example, how sentence structure develop over age with time, whether some languages are mastered earlier? And of course, if you do see those, how do you disentangle the language from, let's say, the culture, the particular country?
Right, okay, so these are several questions at the same time. Of course, in some of the things that we're doing, we also see cultural differences. I wouldn't expect to see cultural differences when it comes to language and age. Different languages, of course, do are more taxing in some respects than in others. In the case of German, this was originally German data. One of the things that is taxing, for instance, is the fact that it is called verb last order, that the subordinating clause, you have the verb at the end, while in English you don't have that. But the influence of some of these factors is still understudied and could actually be studied more. I could go in this further, but perhaps there are other questions. But I'd be delighted to discuss that with you afterwards.
You mentioned that the people are interested that you make a knowledge transfer and hand over to them. How successful is this in general? Because you also mentioned that they often don't have the knowledge about what you're doing.
I think it's even one of the reasons why we say that the background of people is really quite different. And now I can't find the slide on which I have had this remark. So we've both had very successful cases where if you're too successful, then the customers actually really do that on their own next time and don't need us anymore. And we've had cases where we have then subsequent next step together, and also cases where people on the one hand perhaps because the magic wasn't there, but on the other hand also because they didn't manage to use the R and Python libraries themselves, didn't continue. I don't have enough data yet to give you any statistically reliable answer.
So maybe we have time for one last question.
Hello, thank you for your presentation. You mentioned the difference of how people construct their sentences based on their age. Can you, based on your data, can you know if this happens because of the age or because of the generation? Do you have enough data in terms of time for this?
Right. So yes, this data, which yes, we've worked together with colleagues from the psychology department, was collected under the assumption under the test that this is healthy aging. So people who clearly had dementia or other conditions were excluded. So this is about healthy aging. Does that answer your question?
Okay, it's partially answers, but I also meant like generation in terms of like maybe a particular generation talks differently, whether they like, and they keep talking in the same way when they age, or do they change how they talk because they age?
Right. It's of course not a longitudinal study, but some of the people who participated here will actually be invited later again. So, but that, of course, that takes a lot of time. But yes, to different generations, I mean, that also comes back to the cultural question, to society a bit. I've noticed that some of the longest clauses that we find actually come from young speakers, while typically the young speakers have relatively short clauses. So it's a bit of a problem that, of course, we mainly measure average performance, be that means or medians, while in a way we're interested in the maximum capacity. But if you then just only look at the maximum, of course, then you throw away almost all of your data. That also doesn't work. It's the good old distinction, in a way, in linguistics between competence and performance, where we want to measure competence but mainly have the performance. So I'm sorry that I don't really give a full answer to your question, but yeah, it's a bit of both.
Thanks a lot, Carol.
Thank you very much. And yes, if you're interested in knowing more, do get in touch.